So for 42, okay, I'm going to make X 6.75. I'm going to make Y 7.25, or the money invested at that. So then I would say that X plus Y equals 46,000. 0.0675X plus 0.0725Y. If it were to hit the exact amount they want, it would be 3,245. If I'm trying to get, it says what's the most that can be invested at that? Whatever that Y is going to be the most that can be invested at that. If I invest any more than that, I'm going to make more money. I mean, I'm going to accrue more interest. So the more you put in this, the higher that goes, right? The more you'd put in the cheaper side, the lower it would go.
Isn't it asking though for like the one, the 6.5?
What did I say?
6.7?
No, the X. So you're trying to find the X.
Exactly.
Yes.
Okay. How did you get with 267?
You got to move your decimal place 2 units left. Yep.
But that's only for this type of question I have to make.
Right. Normally it's just going to ask you how much to put in it each.
Yeah, no, but like it's only for this question I have to change it to like a decimal.
No, all like this type meaning interest.
Yeah.
Yes, but every single interest question you have to move it, because if it gives it to you in percent, you got to move it to decimal. So this, I think I did substitution here. You could have also done elimination. You just got to be careful. I would say people that make mistakes on this question forget that if they're going to move this back, they have to add on the same amount of zeros on the other side. That's a common mistake made on these kinds of questions. Don't forget, whatever change you make to one of them, you have to make to all of them in that row. And then you could have either done elimination or substitution. You have a calculator, so it's not so bad. Like, I obviously would not expect you to multiply 675 times 4,000 or 46,000 without a calculator, so that's why you're getting one. But you are going to get some big numbers. That's why you have a calculator.
How many zeros did you add at the end?
4, because you moved it 4 times.
So you multiplied it times
10,000. Yeah.
You don't have to do that, right?
No, you could leave it as 0.0675. That's what the work was on the left. I just left it. Just got to be really careful.
Wait, wouldn't the adjustment be 3?
No, because it's 0.0675 when you write it into decimal form, right? This is percent, so in decimals, 0.0675. I'd have to go 1, 2, 3, 4. Yep. So you got to move it to the left first and then move it back to the right if you want it to be a whole number.
Wow, use 90 to divide.
On what?
Why are you moving the decimal back?
So you, in order to get from percent to decimal, you have to move it.
So you just move it the first time.
Right, and then only if you wanted to get rid of the decimal do you have to move it the second time. You don't have to move it the second time.
The second time being where?
The second time over here. Like, I did not move it here.
Okay.
I kept it. You don't need to move it. But if you want to move it, you have to move all of it. This has to get moved, this has to get moved, and the 4 zeros have to get added on the end there. And that's where people make a mistake. Yep. Which one? All right, so 10 has x equals y plus 3 and x equals y squared plus 1. As soon as you see the squared and the non-squared, realize that this is going to involve factoring. So I want to combine these. You could either do substitution. So I could take this and plug it in for the x here, and I'd get y plus 3 equals y squared plus 1, and I'd get everything to one side, and I'd factor it. Or you can do elimination. I could change all these signs. These are going to cancel. I'd get y minus y to the second, and then plus 3 and minus 1. So you can combine all that, which becomes plus 2. Either way, you end up with the y squared and the y. So if I had done it in the red, I would have moved everything to the other side just to keep my y squared positive. I would have gotten y squared minus y minus 2. If you follow the blue, I would have moved this over here, and I still get y squared minus y minus 2. So then I have to factor that equals 0. I have to factor it. So factors of -2 that sum to -1 would be -2 and +1. And then I would split and solve this, and I get y equals 2 and y equals -1. So this tells me I have two solutions, and then I need to solve for x in each. If it was already set up the way this blue one was initially, or actually either of them, I could take the first one. It's x equals y plus 3. I would say it's easier to plug it in there. Oh.
Is there a file with the work from this?
Is there what?
A file with the work?
Yeah, that is on there, right?
No, it's just the original.
Yeah, there's some with.
And then -1, I'd plug in x equals -1 plus 3, and x equals 2. So that should be the two solutions if it's squared. Okay, so this time it says perimeter of a rectangle is 86 feet, and the width is 8/9 times its length. Find the dimensions of the rectangle. So we're back to perimeter in that I need to know perimeter equals twice the length plus twice the width. But then it says that the width is 8/9 times the length. Width should always be smaller than length if that helps you at all. But this isn't like a this is this much more, right? Where we have to take it and add to it, or twice as long. It's 8/9 as long. So the width equals 8/9 the length. Would look like that. And then the perimeter is 68 feet. 68 would equal twice the length plus twice the width. So I would say that this is set up for substitution. I would take this and I would plug it in for the W. 68 would equal twice the length plus 2 times 8/9 the length. So I get 68 equals 2L plus 16/9. I need to find a like denominator there. Or you can multiply everything by 9. That's up to you. But like denominator, this would make this 18/9. And I'd get 68 equals 34/9. And then I could multiply each sides by 9/34. This goes in twice, and I end up with the length being 18. And then the width equals 8/9 that. 9 goes in 18 twice, and W is 16. Yep. Mm-hmm. Okay, this was 58. So if I take out the x on the bottom, I get x squared minus 4x plus 4. And then that's x minus 2 and x minus 2. So this is your repeated factor. I would get a over x plus b over x minus 2 plus c over x minus 2 squared. You got to build up to it. 58. Then we multiply out by what's missing, right? So the a gets both x minus 2 squareds, which is this. Save yourself the trouble of refoiling it out. This would be x squared minus 4x plus 4. A is going to get multiplied by that. B is missing the x and an x minus 2. C is just missing the x. So I'd get 2x squared plus 3x minus 3 equals, I'm going to multiply the a times the x squared there. So I don't have to keep writing it out. Ax squared minus 4ax plus 4a. Oh. Then I do bx times x minus 2. So plus bx squared minus 2bx. And then just cx. And then we group all the coefficients. So everything that's squared, 2x squared equals ax squared plus bx squared. And I would cross them out so you know they're gone. Then I go to the x. And I get 3x equals, this is a negative, so be careful there, negative 4ax minus 2bx plus cx. Again, gone, 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 gone. And then the last one is the negative 3 and the 4a. If you go back through and cross through your x squareds, you end up with 2 equals a plus b. go through and cross out your x's. You end up with 3 equals negative 4a minus 2b plus c. And then the last one, there's no x in. We can actually solve this one. And I get a equals negative 3/4. I'll tell you, I made these whole numbers too on your test. So the regular partial fractions, you can get a fraction as your a, b, c, or a, b. But the repeated one, I made whole numbers. All right, so then a goes in over here. 2 equals negative 3/4 plus b. And then add the 3/4 and add the 3/4. This becomes 8/4 plus 3/4 or 11/4. And then the middle one, 3 equals negative 4 times negative 3/4 minus 2 times 11/4 plus c. These cancel. 3 would equal positive 3 because it's a negative and a negative. 2 goes into 4 twice, so minus 11/2 plus c. You can find a like denominator and multiply everything by 2 to get rid of it. It doesn't matter. So which would you have done, Dylan? Would you have multiplied by 2 to get rid of the 2, or would you have just found the like denominator? Okay, so I'd get, this would be 6/2. 2 equals negative 5/2 plus c. And then add the 5/2. So 4/2. And c is 9/2. Oh yeah, thank you. I rewrote it wrong. 3. So this would be 6/2, and that would be 11/2. Thanks, Vicky. So now the a went over just x. So this would be negative 3/4 over x. The b went over the 11/4 went over the x minus 2. And the c, 11/2, went over x minus 2 squared. You cannot, and like I said, I made the repeated factors whole numbers, so at that point they should be whole numbers, but your regular partial fractions, you're probably going to get a fraction. You got to make sure you take the denominator and you bring it down. And I get negative 3/4x plus 11/4x minus 2 plus 11/2x minus 2 squared. Correct. Especially this time because they weren't all the same denominator. Like if I take out a 1/4, I actually have to multiply the 11 by 2, which is a nightmare. So you don't have to do that. You could just leave it. Don't distribute, especially don't distribute the squared. That would be wrong. Like the other ones wouldn't be wrong, but you don't need to distribute. But you can't distribute the squared there. I said that there could be fractions on your regular partial fraction questions. But for the repeated factors, I made them whole numbers. And I say this only for tomorrow's. So I have not even made the makeup. I'm not saying that I'm going to make fractions on your makeup. It's not like a threat to not take the makeup. But it takes a lot of work to make sure these work out nice and even. And the more tests I have to make, the harder it is to do that. So if you are like, you know, maybe tomorrow, end of the day, and you're like, I'm not ready to take this, I'd rather take the makeup, don't do that. Okay? Just be ready by tomorrow.
No pressure.
No pressure. Yeah. Okay, so first thing was obviously to rewrite it very carefully because if you rewrite it wrong, you've now created a completely wrong system, right? So the ones are in the top left. What was step 2 for you?
I did negative 2 times rho 1 plus rho 2.
So row 2 should now be 0, -1, -6, 0. Did you get that?
Yeah.
Okay. Then what'd you do?
Then I did rho 1 plus rho 3.
Okay. And you get 0, 2, 2, -1. Mm-hmm. Then what'd you do?
Then I did, I don't know if this part I could do, but I did -1 times rho 2. Is that fine?
To get the 1 there?
Yeah, like to divide.
Mm-hmm.
it out,
Yeah.
-1 over 1.
Then what?
Then I did -2 times row 2 plus row 3. Wait, I did it to replace.
Oh, yeah, sorry, so sorry. That's the right thing to do.
Then I did -1 times row 3.
So z is 1/10, which is right for this question. Obviously, if this is your test, that should be a whole number. That should be your first indication. Like that would, if that's a whole number, okay, at least I know I'm on the right track. Now that's row echelon form, right? So now we do the back substitution part.
Oh, I thought you had to.
I think the directions probably said Gosh Jordan, but tomorrow's test is going to have these directions. So let's do it like that, okay? I'm going to keep going, though, in a minute. But I, like, answer the first question using back substitution. So I'm going to do this. So I already know z is 1/10. Then I'm going to take that and plug it in. So y plus 6 times 1/10 equals 0. This would be 3/5. Y plus 3/5 equals 0. Y would equal -3/5. And then I'm going to take the z and the y and plug it into the top. So x minus 3/5, God bless you, plus 4 times 1/10 equals 0. This would be 2/5. And x is 1/5. Then you would flip the paper over, and the back side's going to say, rewrite your row echelon form from number, I think it's 10 and 11, and finish it using Gauss Jordan. So I would come back to this one. That's my row echelon form. X was 1/5. Yeah, 1/5, -3/5, and 1/10. But if you kept going, that's where we'll go from here. And I said it yesterday, I think, but you have to be so very careful when you rewrite this. You don't want to rewrite it wrong and then have to do it again. And it's like on the back side of the paper, so you're going to go back and forth, back and forth. Just be really, really careful. Now what?
Then I think that's why I messed up. I did -6 times row 3 plus row 2.
That's right. So 6/10 is the same thing as 3/5, -3/5. There's your y.
But don't you say keep going?
Mm-hmm. Now what? That's where you got stuck. So I need a 0 here where the 4 is. There's only one way to get that 0, and it's with row 3. So I do -4 row 3 plus row 1. That 0 you will only be able to get with row 3. So -4 here is 2/5. So I did -4 times row 3. Now I add it to row 1. And that replaces row 1. And then the last thing I have to get is the 0. I was the 0 where the 1 is on row 1. And you can only use row 2 now. Yeah, and it doesn't matter which one. You can make -1 row 2 plus row 3. At least you keep that one positive at the front. I mean, plus row 1, sorry. So 0, -1, 0, 3/5, 1, 1, 0, -2/5. And that replaces row 1.
But isn't the middle one gonna end up being -1?
Yeah, but only temporarily. I'm only changing it, right? So now x is 1/5, y is -3/5, z is 1/10. Same answer as the first method.
Are they gonna have fractions like that?
Mm-mm. You might have fractions in your build depending on how you do it, but your answers for these should not be. The systems with 2 variables, you might get 1 or 2 that have a fraction in it, but they're not crazy fractions. But these will all be whole numbers.
So we're not doing 3 variables like solving?
Well, you just did. You're just using this instead of, you mean the new 1, new 2?
Yeah.
Yeah.
We're not.
It is not on there. Yeah. Mm-hmm.
Is there a specific order that we have to do this?
The-
Do we have to find the second zero?
There's not a specific, I just kept giving like the same pattern because normally people are creatures of habit and then it's easier. But it's not that you have to do it that way.
So it's like this out?
And then up and over, yeah. Especially the last 3 zeros, there's not a specific order you need to do it. Like Dylan was saying, do I have to do that in that order? No, like if you look here, like if I'm on this step and you see, God bless you, that it's easy to do the 1s then before the 4, it doesn't matter, you could do the 1s. You have the first ones, like you don't want to get this, if you're working from the very beginning, you don't want to get like this 1 before you get that 0 because you could just lose it again. So you want to do the zeros in the rows before you do the 1s in that row. But the other orders, you could go into different order.
Yeah, because I'm doing one right now where it's easier to do where the 1 is on the second row.
Yeah.
Give me the 0 on the bottom.
That's fine. Yep.
So for 94, would we do the same thing you would want us to do?
So I did the work on it for 94. I did the work on it. Where's that next? All right, so this is 94. We're going to do it the exact same way as the test is going to do it. So the first question is going to say use Gaussian elimination with back substitution to solve this system. So the first thing I'm going to do is rewrite the matrix. So 1, -3, 1, 2, 3, -1, -1, -6, -1, 1, -3, -2. Now, if I have like even a moment's breathing room, I'm going to stop and double check I wrote that right. Because if you start here wrong, obviously everything after here is wrong. Now, this one is already in the 1 at the top. If it wasn't my first, like if 1 and 2 were switched, I would switch them first. So now I want to get a 0 where the 3 is. How could I do that?
R3 plus R2.
Yes, and I heard another one. Multiply the bottom by 3. Yep, that's what Anna said, right? 3R3 plus R2. I also heard something else. The top by -3 plus R2. Both of those will work, okay? So -3, or +3, sorry. Row 3 would be -3, 3, -9, -6. And then row 2, 3, -1, -1, -6. I get 0, 2, -10, -12. And that takes the place of row 2.
Wait, so, but you could also do the top by.
Yep, you'll get a different row echelon, but your answer should be the same and your reduced row echelon should be the same.
Can you do 1/2 row 2?
Sure, I could do 1/2 row 2 right now to get the 1. If it didn't go in evenly to all those, I would say do not do that yet. But because it does go in evenly, I could certainly do that. So 1/2 there.
Why would you?
Because you know that 2 is going to have to become a 1 some point.
Yeah.
So you can do it. If not, if you didn't see it, then don't worry about it. If you want to go straight to the -1, go there.
Okay.
So I'm just going to do that one. Since we said this would be 0, this would be 1, this would be -5, -6. Now I want a 0 where the -1 is. How do I do that?
Row 3 plus row 1.
Good. Row 1 plus row 3. So 1, -3, 1, 2, -1, 1, -3, -2, 0, -2, -2, 0. And that takes the place of row 3.
Wait, so you multiply the top
I didn't. I just added them.
Oh.
Because one was negative, one was positive. Remember, yours is going to be different if you did that first step different.
Should you do then negative 1/2 row 3 as well to cancel
Sure.
row 2s, so that
Sure.
it's easier?
Yep. So if I want a 0 here, your two options right now are take row 2, multiply it by 2, add it to row 3. You could totally do that. Or because, again, I mean, you could get the 1 there. You might also lose it. So if I get a 1 now, but then eventually I'm going to have to go get this one to be a 1, it may be, if it was a different number, I would say don't do it. Only because it's going to also get you that 1 there. Might I do it? But normally I would say more often than not, we want this 0 first. So I'm going to do that one first. But you're not wrong.
So I didn't do the divide.
Okay, so I want a 0 where the negative 2 is. So I'm going to do 2 row 2 plus row 3. In order to get this 0, you have to use row 2 and 3. Otherwise, you lose the other 0 you already got. So 2 row 2, 0, 2, negative 10, negative 12, 0, negative 2, negative 2, 0. 0, 0, negative 12, negative 12.
Are you allowed to multiply by just a negative?
Yeah. 0, 1, negative 5, negative 6, 0, 0, negative 12, negative 12. So now with row echelon, the last thing I need is a 1 where that negative 12 is. How do I do it?
Negative 1 over 12.
Good. Reciprocal. Negative 1/12. And that might be a yucky number, but as long as it goes evenly into the z, and I get a whole number here, at least I know I'm on the right track. So if that's not a whole number and you have the time, go back and try to figure out what you did wrong. If you are short on time and like this is all you got, I'd rather you power through with it wrong and actually finish it than go back and start it all over again and then not even get to number 10 and number 11. So the last class they said, should we go all the way to 10 and 11 first? If you want to, sure. If you're good on time, just don't get hung up on a word problem. You get hung up on a word problem, that's maybe 7 or 8 points. Skip it. Keep going. Then get to the end and go back to it. It would be way worse to not finish all the matrix questions than it would be to skip that one word problem, okay? All right, so now I've got it in row echelon form. Comes the back substitution part. So x minus 3y plus z equals 2. Y minus 5z equals negative 6. And z equals 1. I take the 1, I plug it in. Y minus 5 times 1 equals negative 6. Y minus 5 equals negative 6. Add the 5. And y equals negative 1. And then I take both of them and plug them back in to the top. So x minus 3 times negative 1 plus 1 equals 2. X plus 3 plus 1 equals 2. X plus 4 equals 2. And x equals negative 2. So my answer is negative 2, negative 1, 1. And that's the 20-point question. So the directions literally on the back side now say, rewrite your row echelon form from number 10, which is this question, and then solve it using Gauss-Jordan. So I rewrite this as carefully as you possibly can, as carefully as you've ever written anything before, okay? 1, negative 3, 1, 2, 0, 1, negative 5, negative 6, 0, 0, 1, 1. And you get cocky, and you're like, I did that right. Then you're going to stop, and you're going to go back, and you're going to check it and make sure you wrote it right. Because, again, you write that wrong, you screwed yourself from there on out, okay? Yeah. We're going to finish this one using Gauss-Jordan, right? So now I'm going to work my way back up with the zeros. I need a 0 where the negative 5 is. How could I do it? You have to use row 2 and 3 to get this first one. So 5, row 3 plus row 2. If you use row 1, you lose this 0. That's why you can't use it. So I'm going to multiply this times 5. So 0, 0, 5, 5, 0, 1, negative 5, negative 6. 0, 1, 0, negative 1. And that takes the place of row 2. Now I need the 0 where the 1 is. And again, I have to use row 3. There's a 0 in row 2, so there's nothing I'm going to be able to multiply that by to cancel out the 1. I can multiply row 3 by negative 1. Is that what you said? Yeah. So negative 1 R3 plus R1. I don't want to change. I don't want to do R1 by negative 1 because then I'm going to make this a negative 1 when I put it back in. So I change R3. So R3 times negative 1. 0, 0, negative 1, negative 1, 1, negative 3, 1, 2. And I get 1, negative 3, 0, 1. Takes the place of row 1. Now I want a 0 where the negative 3 is, and I have to use row 2, right? Good. 3, row 2 plus row 1. And that takes the place of row 1. And there's my answers again. X equals negative 2, Y equals negative 1, Z equals 1. And that should match the same answer you got for 10. Somewhere you made a mistake. Yeah. So like this test could be finished in like 30 minutes and you could be sitting there twiddling your thumbs if you get it all the way right the first time. The hardest part of what, like last year everybody kept saying, I had this one kid that would ask, is it time aggressive? It becomes time aggressive if you make a mistake. If you make a mistake and you have to go back and do it again, obviously that's when it starts to mess with your time. But can it be done in less than the time? Absolutely, especially if you're careful in the beginning. And then you get the time of checking your answers because every single system can get rechecked. So you can know, like minus even the partial fractions, you can work backwards and see if it's a question. This is one of those tests where if you had the time, if I gave you back your test and I gave you all the time in the world, you should be able to look at all your answers, work backwards, and figure out if you're right. You just may not have a ton of time. Questions? All right. I did the work exactly the way we just did. Do it using Gaussian elimination with back substitution and then finish it doing Gauss shorten. So if you look at, but again, it doesn't mean like every single step you do has to match every step I do because a different row echelon form doesn't mean it's wrong. A different reduced row echelon is wrong, obviously. But you want to kind of just check your answer. There's going to be multiple ways to do this, which is why grading these is a nightmare because you guys tend to do them differently and it doesn't mean it's wrong. Yeah.
So the equilibrium point question?
Not on here. Yeah, equilibrium is not on the test. I took it off. Break even will give you an initial cost, a variable cost, and then an initial, whatever you're going to make. So you're selling something, some kind of item. I don't know. What do you want to sell? Shoes. Okay. How much are those shoes?
$10.
These are cheap shoes. I like these shoes. $10. But let's make it difficult. It'll be like $10.25, right? It's not going to be a nice round number, right? Per pair of shoes. That's the selling price, so that's your R. R equals 1025x. Okay? The machine to make these shoes, right? The machine to make the shoes costs how much? How much did our machine to make the shoes cost?
Oh my god. Nicole, it can be no shoes and then we can sell socks.
Okay. All right, we're going to say it costs, I don't know, $3,500, okay? And each shoe costs, we're going to say $7.50 to make. It has to cost less per shoe than you sell it for, okay, in this scenario. So then the cost is 7.5x plus the upfront cost, which we said was $3,500. So the break even is 7.5x plus 3,500 equals 10.25x. We're going to subtract 7.5. I don't even have my calculator. So this is 1,272.7. Remember, it doesn't matter what that decimal is. What do we do with break even? Round it up. So this goes up. Even if it would have, by rules of rounding, gone down, we round it up. So that's how much you would have to sell. So you're going to set up your revenue, you're going to set up your costs, and you just set them equal to each other. Yeah.
This is the only one where it's like, it could be like 25.1.
Correct. You always round it up. Mm-hmm.
Listen to me. Our first.
Here's our word problem. You're selling Gosh Jordan shoes for $100.23 per pair. You invested $1,257, which is not a lot of money for selling $75 shoes, but it's okay. Into this shoe selling business, it costs $75.32 to make each pair of shoes. Find the revenue and cost functions, and then the number of shoes you need to sell in order to break even. So my revenue is what? It's how much we sell them for. So it would be $100.23 per shoe. That's going to be one part to your answer. R equals, and then you write the equation. Then it says C equals. So how do I find the costs? Good. Now, how do I find the break even? Set them equal to each other. 123x equals 75.32x plus 1257. And then I'm going to subtract 7532.
So tomorrow we are gonna have to create our own equations.
Yep. Not word problem, but cost and revenue. Yep. 24.91x equals 1257. And then divide both sides by 24.91. And then I get x equals 50 point, it would be 50.5, but it doesn't even matter, right? Because if it's 50 point anything, I do what with that number? I got to round it up. So I need to sell 51 pairs of shoes. Okay. That's it. It is. It should be super easy, but people get it, and then they're like, I don't know how do you figure out the revenue cost function? We've done this 17 times now. Okay. If by chance you get a negative number, you switched your revenue and your cost. Like you did something wrong there.